My name is Muhammad Alif Najmi, and my metric number is B122420038. So, introduction. A dual adjustable DC power supply is an important electronic device used to provide both positive and negative DC voltage for electronic circuit, especially for applications such as operational amplifier that require dual polarity supply. This project designs a simple dual adjustable DC power supply that can produce positive 5 to 25 volt and negative 5 to 25 volt with a current up to 1A using LM7805 and LM7905 voltage regulator IC. These regulators are chosen because they are easy to use, stable, and have built-in protection features. By adding external component, the fixed regulator can be adjusted to give a variable output voltage, making the power supply suitable for laboratory testing and general electronic application. So next, we go through purpose system. The purpose dual variable power supply is designed to provide both positive and negative adjustable DC output in the range of positive 5 to 25 volt and negative 5 to 25 volt at the current 1A using the LM7805 and LM7905 IC. The system start with 240 volt AC input, then is stepped down to 24 volt AC using a center tap transformer, then rectified by a bridge rectifier and filter by capacitor to produce smooth DC voltage. The LM7805 and LM7905 regulate the positive and negative rail, and by adding potentiometer, the output voltage can be adjusted within the required range. When the potentiometer is varied, the output change accordingly allows precise control of both polarity. This simple and stable design provides a reliable dual polarity adjustable DC power supply suitable for laboratory and electronic testing application.
Assalamualaikum. My name is Nafidas bin Noisham. My matrix number is B122420066. And today, I would like to talk about the simulation of this project. So for the simulation, we use a Proteus app. And in this project, we use a transformer of 25 volts, supposedly. And we use 4 diodes, which is one N4007. And then we use 4 capacitor with 2 different different values, which is one is 2200, which is one of them is 2200 microfarad and the other one is 0.22 microfarad. And then for our project, we use LM7805, which is will give the positive value from 5 to 25. And then next is we use the LM7905, which will give the value of negative 5 to negative 25. So the variable to change the value from 5 to 25, we use a potentiometer at both of the LM7805 and LM7905. And in the simulation, I will use the multimeter to show the voltage of both LM, whether it changed from 5 to 25. So in this, when I press the potentiometer on the LM7805, as you can see, the value of the 5 voltage will increase to 25 voltage. And then at the 7905, when I increase the potentiometer, it will increase from negative 5 to negative 25 voltage. So this is the actual project that me and my teammate has built. So in the left hand side is the actual project from the simulation that we have built using the 4 diodes of N4007. And then from here, as you can see, there's a 4 capacitor with 2 different values. The LM7805, which is at the top, and the LM7905, which is at the bottom. And on the right hand side, as you can see, there's a potentiometer that connected to the board, which is to change the value from 5 to 25, and to measure the value, we will use the multimeter. So as we simulate the actual project, the result that we get is, first is we get the we get the positive 5 volt on the early stage when we turn on the transformer. And then when we turn the potentiometer will get the 23 volt. This is because the transformer that we use is only have 24 volts, so that the result from the actual project will not come as the assignment required. But it is still in the range of the value that the assignment want. So the negative part, when we turn on the potentiometer at the negative side, it will show that -5, and then when we turn the potentiometer, it will give the value of -23.01. So in this simulation, as you can see, when we put the voltage, it become the 5 voltage, and when we turn on the potentiometer, it will comes around 23 volts, which is close to 25 volts. And for the negative side, when we did not did not touch the potentiometer, the value is -5, and when we turn on the potentiometer, it will the value will come around 23.01 volt, which is close to -25 volts as the assignment one. So all that is all for me for the simulation, and thank you.
My name is Abdurazik Beazari and my metric number is B122420001. As my fellow presenter present about, I will conclude all about our design. In this experiment, a dual adjustable DC power supply was successfully designed and tested using LM7805 and LM7905 used voltage regulated integrated circuit. Throughout this experiment, the power supply exhibits stable voltage regulation under no load and moderate load condition, with output current capability reaching out to approximate 1A when adequate heat sinking was provided. The built-in protection feature of the LM7805 and LM7905, such as a thermal shutdown and current limiter, contribute to the safe and reliable operation of the circuit during testing. Minor voltage drop were observed at a higher load current, which are constant with the inherent limitation of linear voltage regulation. Overall, the experiment verified and fixed voltage regulator can be adapted into adjustable power supply using a simple external component. The construction dual power supply is suitable for laboratory use, particularly for circuit require dual polarity voltage such as operation amplifier application. This project enhances practical understanding of voltage regulation, dual power supply design, and real world performance consider of linear regulator. That's all from me. Thank you.